Welcome to Beyond the Bracket. Today we'll understand how to determine the rank of a matrix by reducing it to its normal form. Before we start solving the questions, let's go through the procedure step by step with this matrix. While reducing the matrix to its normal form, we can use both row and column operations. Our aim is to reduce this matrix into the identity matrix where diagonals will be 1 and all the other elements will be 0. To do that, we'll start by making this element as 1, making these elements as zeros using R1, followed by making these elements as zeros using C1. In the next step, making this element as 1, followed by making these elements as zeros using R2, and then reducing these elements to zeros using C2. Then this will be made as 1. So every m cross n matrix of rank R can be reduced to the form IR by a finite chain of elementary row and column operations where IR is I-rowed identity matrix. The first question asks us to find the rank of the matrix by reducing it to its normal form. We'll start by making this element as 1, so the operation will be interchanging R1 and R3. Next, we'll try to make these elements as zeros using R1, so the operations will be changing R2 as R2 minus 3R1, R3 as R3 minus 2R1. So the first row will be written as it is. For the second row you get 3 minus 3, minus 2 plus 9, 4 plus 3. For the third row you get 2 minus 2, 3 plus 6, 7 plus 2. For the next step, we will try to make these elements as zeros using C1. So the operations will be changing C2 as C2 plus 3C1, C3 as C3 minus C1. So now the matrix will be written column wise. So the first column will be written as it is. For the second column, you get minus 3 plus 3, 7 minus 0, 9 minus 0. For the third column, you get 1 minus 1, 7 minus 0, 9 minus 0. Before moving on to the next step, to ease calculation, we can divide R2 by 7 and R3 by 9. So this will be the simplified matrix. Next step will be making this element as 1. For this matrix, this element is already 1. Next, we'll try to make this element as 0 using R2. So the operation will be changing R3 as R3 minus R2. First two rows will be written as it is. For the third row, you get 0 minus 0, 1 minus 1, 1 minus 1. Next, we'll try to make this element as 0 using C2. So the operation will be changing C3 as C3 minus C2. Again, the matrix will be written column wise. So the first two columns will be written as it is. For the third column, you get 0 minus 0, 1 minus 1, 0 minus 0. So the given matrix is of the form I2 and the rank of this matrix will be 2. Let's look at another example. This is the given matrix A. We'll first try to make the first element as 1, which is already 1 in this matrix. Our next step will be making these elements as zeros using R1. So the operation will be changing R2 as R2 plus 2R1, R3 as R3 minus R1. Again, the first row will be written as it is. For the second row, we get minus 2 plus 2, 4 plus 4, 3 plus 2, 0 plus 0. For the third row, we are subtracting third row from the first row. 1 minus 1, 0 minus 2, 2 minus 1, minus 8 minus 0. Our next step will be to make these elements as 0 using C1. So the operations will be changing C2 as C2 minus 2C1, C3 as C3 minus C1. And the first element in the fourth column is already 0. So again the matrix will be written column wise. First column will be written as it is. For the second column you get 2 minus 2, 8 minus 0, minus 2 minus 0. For the third column 1 minus 1, 5 minus 0, 1 minus 0. And the fourth column will be written as it is. Before we move on to the next step, if there is something common in any row or column, we can divide that so that the matrix will be simplified, which will ease our calculation. We can observe that in column 2, 2 is common, and in column 4, 8 is common. So the operations will be changing C2 as C2 divided by minus 2, C4 as C4 divided by minus 8. This will be the resultant matrix. Our next step is to make this element as 1. To do that, we can interchange R2 with R3. So after interchanging, we'll make this element as 0 using R2. So the operation will be changing R3 as R3 plus 4R2. Again, the first two rows will be written as it is. For the third row, we get 0 plus 0, minus 4 plus 4, 5 plus 4, 0 plus 4. To make these two elements as 0 using C2, the operation will be changing C3 as C3 minus C2, C4 as C4 minus C2. Again, the first two columns will be written as it is. For the third column, we'll get 0 minus 0, 1 minus 1, 9 minus 0. For the fourth column, 0 minus 0, 1 minus 1, 4 minus 0. Always, before we move on to the next step, we'll check if the matrix can be simplified. If you observe in column 3 and column 4, there is 9 and 4 common. So the operation will be dividing C3 by 9 and C4 by 4 to get more simplified matrix. Our last step is to make this element as 0 using C3. So the operation will be changing C4 as C4 minus C3. Again, the first three columns will be written as it is. For the fourth column, we get 0 minus 0, 0 minus 0, 1 minus 1. So the given matrix is already reduced in normal form and rank of this matrix is 3. Let's quickly look into another example. So here our first aim is to reduce this element as 1. This can be done in various ways. Either we can interchange R1 with R3, or we can interchange R1 with R4, or we can just divide R1 by 2. Dividing R1 by 2 further simplifies the matrix also. So we'll proceed with dividing R1 by 2. Also there is 2 common in R2, so we'll divide R2 with 2. So this will be the resultant matrix after doing both the operations. Now our next aim is to make these elements as zeros using R1. So the operations will be changing R2 as R2 minus 2R1, R3 as R3 minus R1, R4 as R4 minus R1. The first row will be written as it is. For the second row, we are subtracting second row minus 2 times first row. So it will be 2 minus 2, 1 plus 2, 0 minus 0, 1 minus 6. We are subtracting third row from the first row. So we get 1 minus 1, minus 1 plus 1, 0 minus 0, 3 minus 3. Fourth row minus first row, we get 1 minus 1, minus 2 plus 1, 1 minus 0, 2 minus 3. The next step is to make these elements as zeros using C1. So the operations will be changing C2 as C2 plus C1. This element is already 0. C4 as C4 minus 3C1. So the first column will be written as it is. For the second column, we get minus 1 plus 1, 3 plus 0, 0 plus 0, minus 1 plus 0. Again, the third column will be written as it is. For the fourth column, we get 3 minus 3, minus 5 minus 0, 0 minus 0, minus 1 minus 0. Our next aim is to make this element as 1. So for that, we can interchange R2 with R4. This element can easily be made as 1 by changing R2 as R2 divided by minus 1. Also, R3 is a 0 row. We already know that 0 rows should be below the non-zero rows. So we'll interchange R3 and R4. This will be the resultant matrix after both the operations. Our next step is to make these elements as 0 using R2. So the operations will be changing R3 as R3 minus 3R2, and the last element is already 0. The first two rows will be written as it is. For the third row, we get 0 minus 0, 3 minus 3, 0 plus 3, minus 5 minus 3. Last row is written as it is. Next step is to make these elements as zeros using C2. So the operations will be changing C3 as C3 plus C2, C4 as C4 minus C2. Again, the first two columns will be written as it is. For the third column, we get 0 minus 0, minus 1 plus 1, 3 plus 0, 0 plus 0. For the fourth column, we get 0 minus 0, 1 minus 1, minus 8 minus 0, and 0 minus 0. Making this element as 1, in the next step, we can divide third column by 3. So the next operation will be C3 as C3 by 3. For the last step, this element is to be made as 1 using C3. So the operation will be changing C4 as C4 minus C3. Again, the first three columns will be written as it is. For the fourth column, we get 0 minus 0, 0 minus 0, 1 minus 1, 0 minus 0. Here, the matrix is reduced in normal form and the rank of this matrix is 3. To help you practice, I have included a few questions along with their answers for your reference.